Hello everybody. For our group project, we decided to base it off of smoking booths, areas that smokers are allowed to smoke in without really bothering non-smokers, affecting their health, those type of things. We think it's a really good idea, a really relevant topic in Korea because I think around 20% of the population of the country smoke, and too often we see this in public areas, and we want to try to reduce that. So the problem, too many people smoke in public areas. I often see it on streets and it's really bothersome to me. I start coughing. No smoking areas in Seoul has increased, usually because of laws. So now people aren't allowed to smoke on public areas like on the street. And this creates a problem because all it does is increase people smoking in public areas rather than limit the smoke use. So because it's such an inconvenience for them to go to areas where it's not allowed to, the more likely to break the law, and then more likely people will suffer secondhand effects from this. So our statement: do they use the GIS and other obtainable data found on the internet? We want to install booths strategically throughout the city where it's most convenient just for smokers to go to and smoke, and also not really harm the health of other people at the same time. With regards to important factors such as how far away should we put these booths from schools, hospitals, and other areas like that.
We will use existing smoking booths location data to decide quotient reflect which parameters are important. We decide to use Delaunay triangulation to perform data mining, classification to extract a significant cluster from a given data distribution. Discrete points, that means existing smoking booths location, and we will obtain density of points with Delaunay triangulation. As you see, the density of P is 1 over sum of the area triangle around. Scientists use this density to cluster data and analyze. We knew existing smoking booths location in form of latitude and longitude, and we used MATLAB to make Delaunay triangle with function of dt. The result of coding, we could obtain the Delaunay triangle. X-axis is longitude and y-axis is latitude, but this is not reflected map projection, so this is not exact value. So we used Delaunay triangulation tool in QGIS program. This picture shows exact triangles. We used the coordinate system GRS 80 Central. We got densities of each 31 point, excluding the outermost point. Low density value means high importance of the point. So we found correlation with variables that are smoking population, floating population, and complaints of corresponding GU. In conclusion, quotient of smoking population is 1, quotient of floating population is 7, and the quotient of complaints is 1.2. This means floating population governs location of smoking booths.
The screen now is the data that our group has acquired. The source of the data is the Seoul Metropolitan Government Public Data Portal. With this data, we will find out how many smoking booths we are going to distribute in each GU. As I explained earlier, smoking data is needed to get the quotient. So the code we have to input the MATLAB is XLS read file name, sheet number, column number. The number of smoking people is located in 흡연 인구 file name and first sheet and column C. So we can input the code to load the data. Here is the floating data. The original data is ratio data, so only we have to do is loading the data and multiply by 100. The reason multiplying 100 is to make all variables percent ratio. The next variable is complaint data. We can load the data by inputting the code Excel as read. So we can get the quotient. The quotient function is multiplying floating data by 7 plus smoking plus complaint multiplied by 1.2. This is not all. According to the quotient we got, we can distribute the 50 smoking booths. In this process, we have to get the quotient ratio. If we multiply quotient ratio by 50, we can know how many smoking booths needed for each gu. In this process, the price came out in small numbers and we use rounding. The summation of smoking booth is 50.
I'll explain what we did in QGIS software. Basically, we prepared Seoul shapefile to include attributes of each gu and dong. The first step is to add layers from delimited text file in CSV form. These layers are not the geometric data but attributes-only tables. Data we need to put in this tab is the following: number of smokers for each gu, floating population for each gu, severe complaints for each gu, and dong population. Next step is to add vector join. We added all the previous layers as attributes to Seoul shapefile. The important thing is to adjust target field properly. Then you can get a result like this. Then we added layers for non-smoking areas. You can add as a delimited text file as well. In the same way, we added a layer for existing smoking booths. After that, we added a new field in Field Calculator to calculate smoking quotient for each dong. The coefficients were generated by the TFE method, which is mentioned before. If you sort the quotient in descending order, you can find out where is the most reasonable place to install additional smoking booths. Finally, we applied buffering for each non-smoking area and existing smoking booths. This buffered area indicates that there is no need to place additional smoking booths.